Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the video on inclined planes, and in this video I'm going to be going through a specific example. So here we go. A particle of mass 8 kilograms is placed on a rough plane inclined at 15 degrees to the horizontal. If the coefficient of friction between the particle and the plane is 0.2, find the acceleration of the particle down the plane. Right, so first thing I'm going to do is draw a nice big diagram. Here is the inclined plane, and I've been given that this angle here is 15 degrees, and I've got a particle of mass 8 kilograms. So I'm just going to draw that there, move it over and line it up. I'm just going to write in there that that has got mass 8 kilograms. And I'm also told in the question that the coefficient of friction is 0.2. So I'm just going to jot that one up there. 0.2. I'm perfectly safe, by the way, it's just storm units. And we're being asked to find the acceleration of the particle down the plane, which means that the acceleration is going this way, parallel to the plane. Now, let's just consider the forces acting on this particle. We've got its weight, which is going straight down, which is 8g. We've got a normal reaction force, which is acting perpendicular to the slope. And we're going to have a frictional force, which is acting against the direction of motion. Okay, so that's what we've got so far. Now, what I need to do is I need to resolve this weight into its components perpendicular and parallel to the slope. So I'm just going to draw those on with dashed lines. So there's the one perpendicular to the slope, and there's the one parallel to the slope. And if you remember in the previous video, I explained that this angle here is always going to be the same as the angle at which the plane is inclined, 15 degrees. That means that the weight component perpendicular to the slope is going to be 8g cos 15, and parallel to the slope is going to be 8g sine 15. And if you remember in my previous video, I said this is the one that people always forget. Right, now that we've labelled all the forces and separated them into component parts parallel and perpendicular to the plane, we're ready to start resolving. And the first thing that I'm going to do is I'm going to resolve perpendicular to the plane, so forces acting perpendicular to the plane. And what I'd recommend that you do for this is to get a straight edge or a ruler and just slide it down the plane perpendicular to the plane, and make sure that every time you hit an arrow that's going along your straight edge, you're acknowledging it within the resolving forces equation that you're doing. So here, the only two forces I've got is this normal reaction force R and this 8g cos 15. And they must be equal because we're in equilibrium perpendicular to the slope, because the package is just sliding down the slope parallel. So I can use that straight away to find my reaction force as a value. Now remember in maths that we use G as 9.8. So I have the normal reaction force of 75.72. Now I can use that to find out the value of friction, because I know the coefficient of friction. So I can use the formula that F is equal to mu R. Mu is 0.2, and my reaction force I've just worked out to be 75.728. So my frictional force is going to be 15.1457, etc., etc. So that is my maximum value of friction. Right, once I've done resolving perpendicular to the slope and I've found this value of friction, I'm ready to resolve parallel to the slope to find the acceleration. Now, same again, get your straight edge and slide it so it's parallel to the slope, and every time you hit an arrow, make sure you acknowledge it in your resultant force equation. Now I've got two to think about here. I've got 8g sine 15 in the direction of motion, and I've got friction opposing the motion. So when I resolve parallel to the plane, I'm using the resultant force is equal to mass times acceleration. And I've got 8g sine 15 minus my friction, which is 15.457, is equal to the mass, which was 8, multiplied by the acceleration. So I can get a numerical value for this. So doing 8g sine 15 minus 15.457, which comes out as 5.145. Dividing through by 8 and rounding to 3 significant figures, I get an acceleration of 0.643 meters per second. So there we go. Label all your forces and components, resolve perpendicular, resolve parallel, job done. I'll see you in the next video.